Hello, welcome to my video of Campaign T119 Learning Portfolio. If I were asked to use one word to describe this course, I would definitely say enlightening. To be honest, views provided in this course reshaped my cognition and modeling. I struggled with these views, finally understand them. In this video, I'm going to talk about these enlightening views and explain how I understand them. At the end of this video, I will share my understanding of the advantages of model-driven software development from my perspective. At the beginning of this course, Dr. Flint said that the process of producing models is more important than models themselves. But really, at first I was not very convinced because I thought we develop software based on models. If the models were wrong, there would be a big problem for code generation and implementation. But as I learned more about models, I realized that I was wrong. We don't develop software based on models. Actually, we develop software based on full, clear, and consistent understanding of the requirement. Here's a personal experience. When I was doing self-assessment project during my undergraduate, the project requirement was designed all by myself and approved by my supervisor. Of course, I clearly understood my requirements, so I implemented the software successfully without any models. However, the real software development usually involves more than one stakeholder, and usually the person who designed the requirement is not the person who developed the software. So it is not easy for developers to judge whether or not they have clearly and consistently understood the application domain. With the workshop, I realized that modeling is an effective way to examine whether or not we have fully and consistently understood the application domain, because the process of producing models involves a lot of discussions. And these discussions expose different views and ambiguities. To reach a consistency, we are forced to go to stakeholders for more information. The model of this is a byproduct of this process, capturing the consistent understanding and full knowledge of the application domain. So it is the process of producing models that facilitates our full and consistent understanding of the application domain, not the model itself. Let me give a real example happened in my workshop. When we do the workshop model, we abstract persons who grant access as a class, naming it administrator, and abstract persons who request access as another class, naming it employee. Immediately, here comes the question. Is an administrator also an employee of this company? If administrators are employees of this company, we need to specialize employee class into administrator class who grant access and non-administrator class who request access. Then more questions come. Do administrators themselves need to apply for access? If they also need to apply for access, then who approves their access? See, even naming is much more difficult than it looks like. A lot of questions and different views would appear during the process, which cause discussions. When we find something we are not very sure or cannot reach a consistency, we will realize that it is the time to go to stakeholders for help to get more information. So the modeling is the process we deeply study the domain. We discuss and expose ambiguities. Then we think and seek more information. After we get enough information, we can eliminate ambiguities, and finally, we understand the domain better. Second, Dr. Flint emphasized that class diagrams or state diagrams are not models. At first, I was confused. If the class diagram is not a model, then what is a model? Well, the first time I know about model was in my undergraduate Java course. In that course, I learned the Java class diagram, and every time our instructor asked us to do model, we drew a class diagram. So in my previous cognition, class diagram itself was a model. But I realized that I was wrong after I drew two different diagrams in two different courses for same thing, student enrolled courses. In Camp 6240 relational database system, we use the ER diagram to express the enrollment. And in Competi 190, model-driven software development, we use class diagram to express the enrollment. These two different diagrams express the same thing. Students can enroll any number of courses, and they are identified by student number. Courses must be enrolled by at least one student, and they are identified by course number. Each student have a mark on that course. So diagrams are just representations of models. If I write down what I said previously, these words are also the representation of the model. Even my speaking is also a representation of the model. Class diagram, ER diagram, texts, as well as speaking, are different representations of the same model. And model is the ideas in our mind. It is the abstraction of things in the real world. These abstractions can be expressed in many different forms. The last thing is about domain. I have to say that before this course, I totally have no idea about what is domain. In my undergraduate, when we did group works for developing a system, we tended to separate the whole system into several different systems, subsystems, in hope that members can do the work parallel and increase efficiency. But it always works in a very different way from what we were expecting. Although the system was divided into smaller parts, each subsystem is consisted of all subject matters. That means members working in small parts of systems also need to consider sub-database, sub-interface, sub-application, and so on. So dividing systems into subsystems doesn't reduce the efforts, and it would even cause chaos, such as inconsistency and repetitive work. For example, if two subsystems involve the same data, the data will be created twice with different names in two different subsystems. So when we try to integrate these subsystems into a whole system, the data inconsistency happens. Separate concerns into different domains is really enlightening for me. Unlike subsystems, domains are independent from other domains. They concern different subject matter. Then works in different domains can be done parallel without inconsistency and repetitive work. Now I want to talk about how I understand the advantages of model-driven software development. After I learned this course, I found that executable models have 4 good features, and I think these features consist the advantages of model-driven software development. As I mentioned earlier, modeling is an effective way to fully, clearly, and consistently understand the requirement. Dr. Flint said that, judging by the experience, models are not difficult to understand by people with few engineering background. I made a very little test with my roommate, who is majoring in finance. I showed her my workshop class diagram and state diagram. With very little explanation, she could understand the models very well, and she even mentioned that the model works exactly the same way with the electronic lock system of ANU. Every morning before 9 o'clock, she has to swipe her student card to enter the self-studying room in the CBE building. So developers can use models to communicate with stakeholders, and it is not difficult for stakeholders to understand the models. With these communications, developers could better understand what stakeholders really want and expect. Then software product produced by engineers would be more desirable and capable. Models can be used for other purposes, for example, training and teaching. Staff or users need to be taught how to use the software. Models can be used as textbook or instruction book to explain how the software works and what functions it provides. So, as I mentioned earlier, it is not difficult for people to understand models. Compared with source code, models are more readable and understandable. During my undergraduate, I learned accounting information system. In that course, our instructor also used models to explain how the system works. And I found this model-based explanation was very vivid and understandable. Models we learn from this course are based on domains. Each domain is a separate and independent concern. So if the whole system is divided into different domains, experts can be allocated into domains. And developers in different domains only focus on one domain and doesn't need to care about other domains, so works can be done parallel. This increases efficiency. Executable models can be automatically translated into source code and be debugged. It allows validation of behavior at the early stage. If there is something wrong, we can modify the model very easily. The cost for fixing problems in the modeling phase is very low, and this reduces costs later in the process. Moreover, models can reduce risk and the impact of changing requirements. Sometimes, requirement is not confirmed. It will change during the development. Executable models can be updated easily against the changes, compiled, and translated into source code. Compared with updating models, updating code directly is more difficult and time-consuming because there may be thousands of code need to be reviewed. In addition, models are very useful to develop new versions of product. To develop new version product, changes and updates would be made. Engineers can study the impact of these changes by simulating them on the models. New models can be created or updated based on the old version models very quickly and easily to develop the new version product.